Remember how last time you were asking about whether or not AI could design those super intricate devices that can manipulate light?
Uh-huh.
Well, guess what? It turns out it can.
Oh,
We're diving into some fascinating research that combines the world of nanophotonics with the power of large language models.
so like AI that can write poems in code.
Yeah. And now, apparently, they can design some pretty complex tech.
That's amazing.
Yeah.
It's fascinating how these LLMs, which we usually think of as, being used for creative tasks, can actually handle all the complexities of nanophotonic design.
Yeah.
It really highlights just how versatile these AI systems are becoming.
Absolutely. So for this deep dive, we've got 3 research papers,
All right.
and they explore 2 very different approaches.
Right.
One is using something called multilayer films, and the other is focusing on even tinier structures called metasurfaces.
Interesting.
And the thing that I found really interesting is that the way that LLMs are used in each approach is completely different.
Yeah, exactly. So in the first approach, researchers are using LLMs to design multi-layer films,
Okay.
which are essentially stacks of materials that all have different optical properties.
Right.
These films are used in like all sorts of things, filters, mirrors, lenses, you name it.
Hmm.
The challenge is figuring out the right combination of materials and thicknesses for each layer to get a very specific optical effect.
And traditionally, this whole design process requires like a deep understanding of optics, right?
Yeah.
A lot of trial and error.
Precisely. But that's what makes this research so exciting. Because what they're finding is that these LLMs can actually make this design process way more accessible.
Really?
Yeah, so they used a technique called in-context learning, where they basically gave the LLM a crash course on the physics of light,
Okay.
and then showed it some examples of successful multi-layer film designs.
So it's kind of like if you were showing someone a few solved math problems and then gave them a new one to try to solve.
Exactly, exactly. So they basically taught the AI the basic rules of the game,
Okay.
and then the AI was able to apply those rules to all sorts of new challenges.
So what were the results like? Were they good?
Yeah, the results were really impressive, actually.
Cool.
The LLM was able to accurately simulate how light would pass through different multi-layer designs,
Wow.
and even suggest ways to optimize those designs to meet specific goals.
So for example, could you ask the LLM to design something like a filter that would only let through a specific color of light?
Absolutely.
Hmm.
Let's say you want to design what's called a bandpass filter,
Mm.
and this filter would only let through red light.
Right.
You could actually give the LLM that goal, along with all the basic information about how light behaves in these multi-layer films.
Yeah.
And it could actually come up with a design that meets those exact specifications.
That is incredible. So it's like you have an AI assistant that can help you design these complex optical devices, even if you're not an expert in optics yourself.
That's the real game changer here.
Yeah.
This approach could potentially democratize nanophotonic design,
Hmm.
making it accessible to a way wider range of researchers and engineers.
This has huge implications, but beyond filters, what are some other things you could use this for? Like, what are you really excited about?
Well, imagine applying this to the design of more efficient solar cells,
Mm.
or developing entirely new types of optical sensors with, like, unprecedented sensitivity. The applications are just vast.
So it sounds like we could accelerate the development of all sorts of new technologies.
Exactly.
It's amazing. Okay, well, let's move on to those metasurfaces now.
All right.
They sound even more complex than those multi-layer films.
They are. Think of metasurfaces as like the next step up in complexity.
Okay.
Okay, so imagine
Right.
you're arranging these nano-sized antennas on a surface to control light waves in incredibly intricate ways.
Okay.
Instead of layering all these different materials, like you do with a multi-layer film,
Right.
you're manipulating the structure of the surface itself at the nanoscale.
Wow. So we're talking about building structures that are even smaller than the wavelengths of light they're manipulating.
Exactly.
Wow.
And by really carefully designing the shape and the arrangement of these nano antennas, you can actually achieve some remarkable control over light.
Really?
Yeah, you can focus light to like a tiny point. You can manipulate its polarization. You can even create holographic images.
That's amazing. I'm guessing designing these structures is incredibly challenging, though, right?
You're absolutely right. Traditionally, to design these metasurfaces, you need these really powerful simulations,
Okay.
often using supercomputers,
Wow.
just to understand how light's going to interact with these tiny structures. It's a very resource-intensive process.
Okay, so How are LLMs being used to tackle this challenge? Did they give the AI a crash course on metasurface physics too?
So they took a different approach this time,
Okay.
one that really leverages the LLM's strength in pattern recognition.
Oh.
What they did is they trained the LLM on a massive data set of metasurface designs and all their corresponding optical properties.
Okay.
So essentially, they fed it tons of examples of, if you build it this way, light will behave like this.
So instead of teaching it the fundamental rules, they just showed it a ton of examples and let it figure out the patterns itself?
Exactly. Exactly.
Wow.
And it worked. The LLM was able to learn those complex relationships without needing to explicitly understand all the physics behind them.
So what can it actually do with all of that knowledge?
Well, two really cool things.
Okay.
First, it can predict the optical properties of a given metasurface design with crazy accuracy.
So show it a design and it'll tell you how light's going to interact with it, like a virtual light lab almost.
Exactly. So you can essentially test out your design before you even have to go through the trouble of building it.
That's amazing.
The second thing is even more impressive, though.
Okay, what's that?
You can tell the LLM what kind of light manipulation you want, and it can actually suggest a metasurface design that will achieve it.
Wow. So you could be like, I want to create a metasurface that makes this object invisible to a specific wavelength of light. And the AI could come up with a design that would actually do that.
You got it. And that's really where the power of this approach lies.
Mhm.
It's not just about automating the design process. It's about actually expanding our understanding of what's possible and exploring a way wider range of design solutions.
So this is blowing my mind. And you said this research explored two very different approaches to nanophotonic design using LLMs.
Yes.
And in both cases, we're seeing some really incredible results.
Yeah, and it's the LLM's ability to find these patterns and relationships, whether it's in text, in code, or even in the behavior of light itself.
Uh-huh.
That's what makes them such powerful tools for both design and discovery.
This all sounds like something straight out of science fiction, honestly. I'm sure you're just as excited as I am to unpack the implications of this research.
Oh yeah, absolutely. It's amazing.
It really is remarkable how versatile these large language models are turning out to be.
Yeah.
From writing code to designing these nanoscale devices, they just seem to be capable of tackling an incredible range of challenges.
Yeah, it's truly a testament to their ability to just learn and adapt,
Yeah,
you know.
yeah.
What we're seeing is that LLMs aren't limited to just processing and generating text.
Uh-huh.
They can actually analyze complex data, identify all these hidden patterns, and even generate creative solutions in fields that we've always thought of as, requiring human expertise.
Right. And in the case of these two approaches to nanophotonic design that we've been talking about, they're leveraging those abilities in very different ways.
That's right. So with the multi-layer films, the focus is on giving the LLM like this foundational understanding of the physics,
Right.
and then letting it apply that knowledge to, brand new design problems.
Uh-huh.
It's kind of like teaching a student the basic principles of a subject,
Okay.
and then letting them work through a bunch of practice problems to really solidify their understanding.
And that approach seems to be working really well.
Yeah.
At least based on, what we've seen in the research.
Yeah.
But the approach with the metasurfaces is very different.
It is, yeah. Instead of like explicitly, giving the LLM all this knowledge about the physics of metasurfaces,
Okay.
the researchers went with this data-driven approach
Okay.
where they trained the LLM on this massive data set of metasurface designs
Right.
and all of their corresponding optical properties.
So it's more about learning from example than like learning the actual underlying rules.
Precisely. And what's really fascinating is that the LLM can actually extract, meaningful patterns and relationships from this huge amount of data,
Uh-huh.
even without explicitly, being told what those patterns are.
Wow. So it's like a detective piecing together clues to solve a complex case.
Exactly.
And this data-driven approach seems to be just as effective as the in-context learning method.
Yeah, that's right. Both approaches have really clearly demonstrated the potential of LLMs to be these really powerful tools for nanophotonic design. And the fact that they can be applied in such different ways, it really speaks volumes about their flexibility and adaptability.
This raises an interesting question, though. If LLMs can be used to design both multi-layer films and metasurfaces, what other kinds of nanophotonic structures could they potentially tackle? Like, are there any limits to what they can do in this field?
That's a question that researchers are actively trying to figure out.
Yeah.
While this research focused on, just these two specific types of structures, the underlying principles and the techniques could potentially be extended to other areas of nanophotonics.
So we could see LLMs designing even more complex and sophisticated optical devices in the future.
Absolutely, and that's what makes this field so exciting. We're
Yeah.
really just scratching the surface of what's possible with AI-powered nanophotonic design.
Wow.
And as LLMs continue to evolve and get even better, their potential in this field is only going to continue to grow.
You mentioned earlier that this research could, democratize nanophotonic design
Yeah.
and make it more accessible to, a much wider range of people.
Right.
Can you talk a little bit more about that? Like, what does that actually look like in practice?
Well, imagine a world where, researchers, engineers, even students could design and test their own nanophotonic devices without needing, years of specialized training
Right.
or access to expensive equipment like supercomputers.
Yeah.
That's the kind of transformative potential that we're talking about here.
So instead of needing a PhD in optics and a whole team of engineers to design a new optical device, you could potentially do it with just a laptop and an AI assistant.
That's the idea.
Hmm.
Of course, there will always be a need for human expertise and oversight,
Right.
but these AI tools could, dramatically lower the barrier to entry in this field, allowing way more people to contribute to innovation and discovery.
That's a really exciting prospect, but it also kind of makes you wonder, about the role of human expertise in a world where AI is becoming more and more capable. Do you think there's a risk that these AI tools could, eventually replace human designers altogether?
I think it's way more likely that AI is going to augment human capabilities
Okay.
rather than replace them entirely.
Okay.
Think of it as this collaboration between human ingenuity and artificial intelligence.
Right.
Humans can provide the creativity, the intuition, the ethical considerations,
Yeah.
while AI can kind of handle the complex calculations, the data analysis, and the rapid prototyping.
So it's about finding that right balance
Exactly.
between human and artificial intelligence
Yeah,
to achieve the best possible outcomes.
exactly. And I think that this kind of collaboration has the potential to unlock, incredible advancements in nanophotonics and beyond.
We've talked a lot about the technical aspects of this research, but I'm also curious about the broader implications.
Yeah.
What kind of impact could this have on society as a whole? Like,
Right.
what are some of the potential applications of this technology that you find particularly exciting?
Well, imagine the possibilities in areas like, renewable energy,
Mm-hmm.
healthcare communication.
All right.
We could see the development of, more efficient solar panels,
Yeah.
ultra-sensitive medical sensors, even new forms of optical computing.
It's amazing to think that these tiny devices, manipulating light at the nanoscale could have such a profound impact on our world.
And it's important to remember that this research is still in its early stages.
Yeah.
We're really just beginning to explore the possibilities of what AI-powered nanophotonic design can do.
Right.
Who knows what incredible breakthroughs are waiting for us, in the years to come.
It's both exciting and a little bit daunting to think about all the different possibilities.
Yeah.
And as we delve deeper into this world of AI-driven innovation, it's clear that we're entering this new era of scientific discovery.
Definitely.
But before we get too carried away thinking about the future,
Yeah.
let's take a moment to recap what we've learned so far about these two fascinating approaches to nanophotonic design.
That's a good point.
Yeah.
Let's solidify our understanding of the key takeaways from this research.
We've covered a lot of ground in this deep dive. It's been incredible to see how AI is really being used to, push the boundaries in nanophotonics, but beyond the wow factor.
Yeah.
What really stood out to me is just the potential of these LLMs to make this super complex field way more accessible.
Absolutely.
Yeah.
Yeah, one of the most exciting things about this whole research is that possibility of democratizing nanophotonic design.
Right.
Just imagine a world where researchers, engineers, even students could easily design and test these brand new optical devices, no matter what their level of expertise is.
That's a really powerful idea, but what would that actually look like in practice?
Yeah.
Could someone with just a basic understanding of optics and access to these AI tools really make, a real contribution to the field?
I think so, yeah. These LM-based tools have the potential to, really streamline that whole design process.
Okay.
Allowing users to focus on the creative aspects rather than getting bogged down in all the complex calculations and simulations.
So instead of needing years of specialized training and access to those supercomputers,
Right.
you could potentially have a way more intuitive and user-friendly design interface that's powered by AI.
Exactly. Think of it like having a virtual nanophotonics expert right there at your fingertips.
Yeah.
You could just describe the functionality that you want.
Mm-hmm.
And the AI can suggest all these different designs, simulate their performance, and even help you optimize them for specific applications.
That would just like open up a world of possibilities for innovation. We
Oh,
could see this like huge surge in new ideas and applications coming from individuals and small teams that, wouldn't have even had the resources to explore this field before.
exactly. And that's what makes this research so exciting. It's not just about advancing, the science of nanophotonics.
Right.
It's about empowering more people to participate in that advancement.
It's like you're giving everyone the key to unlock that potential of manipulating light at the nanoscale.
Exactly.
But with, any new technology, it's always important to think about the potential downsides too.
Yeah.
Are there any concerns or like challenges that come along with this increased accessibility?
Well, there are always challenges whenever you're, integrating new technologies into existing workflows.
Right.
So it'll be super important to develop these AI tools
Hmm.
in a way that ensures transparency and reliability.
Hmm.
We want to make sure that, users really understand the limitations of these tools
Right.
and they don't just blindly trust the outputs without, doing proper validation.
So it's not just about making those tools accessible, it's also about educating users on how to actually use them responsibly and critically.
Exactly. And that's going to require, a lot of collaboration between the AI developers, the nanophotonics experts, and the end users,
Right.
just to create this, really robust and trustworthy ecosystem for AI-powered design.
It's fascinating to think about the potential impact of this research. We've talked about some, really exciting applications like
Mhm.
more efficient solar cells and ultra-sensitive sensors.
Yeah.
What other areas do you see this technology, really impacting in the future?
Oh, the potential applications are just massive.
Mm.
We can see huge advancements in medical imaging,
Mm-hmm.
optical computing, even secure communication, using quantum cryptography.
Wow.
The ability to manipulate light at the nanoscale opens up a world of possibilities that we haven't even begun to explore yet.
It's crazy to think that these tiny little devices could actually revolutionize so many aspects of our
I
lives.
know, it's amazing.
And it all comes back to, just the incredible power of these LLMs to analyze that complex data, identify those patterns, and generate these creative solutions
Hmm.
in ways that we never even thought possible.
It really is remarkable.
It's a real testament to, the ingenuity of all those researchers who are developing these AI tools and exploring their potential in fields like nanophotonics. Who knows what incredible breakthroughs are waiting for us, in the years to come.
Yeah, it's really an exciting time to be following this field.
It really is. We've gone from AI writing poems to AI designing, devices that can manipulate light at the nanoscale.
Uh-huh.
What's next? It's almost impossible to predict, but one thing is certain, the future of technology is really bright, and AI is going to play a huge role in shaping it. Thanks for joining us on this deep dive into the fascinating world of nanophotonics and large language models.
It's been a pleasure, exploring this cutting-edge research
Hmm.
with you and to all of our listeners out there. We encourage you to keep exploring, keep learning, and keep asking questions. The future is full of possibilities, and who knows, maybe you'll be the one to make the next, groundbreaking discovery.